If you're hearing this, you have found out that I'm not here. Hopefully everything went well with the baby. This slideshow is your introduction to acids and bases. There's just one part of it that could be a little bit confusing, so I wanted to explain it to you. First of all, I just want to give you a brief introduction to what acids behave like. The most important thing and what we're going to do the math of, because that's what we do, is we're going to talk about how acids ionize in water. Last semester we call it dissociate. So basically it's just that it breaks into ions. The ion that we care about is the hydrogen ion. You remember from the periodic table trends that acids react with metals to produce hydrogen gas. This week we're going to be doing a lab where we learn that acids affect colors of indicators, and they neutralize bases and taste sour. You might recall that just from citric acid, or if you've ever tasted vinegar, you know that those taste sour. Bases do the opposite. They neutralize acids. They taste bitter. And then you might have known in this class, if we've used sodium hydroxide and you get it on your finger and you rub your fingers together, it feels kind of slimy. That's because it's a base. We're going to go through two definitions of acids and bases today. The first definition is the Arrhenius definition, which says that when you put an acid in water, it's going to yield a hydrogen ion. This should look familiar to you from when we did formula writing and naming acids, because we know that acids start with an H. Now that's not 100% true. You might recall when we were studying organic that you can have acids, organic acids, that end in a carboxylic group, which is COOH, and that wouldn't start with an H. But really, you don't have to worry about that for now. Just recall that the formula is going to start with an H. And that hydrogen ion is going to immediately react with water to form H3O+, which is the hydronium ion. I put it in red here just because that's a really important ion for you to know. A base, when you put it into water, is going to produce a hydroxide ion, an OH1. I don't know if this is bothering you, but if you look at that cartoon, do you see that the A is uppercase? That's just kind of annoying. The second definition, and this is the one that gets a little bit confusing, is the Bronsted-Lowry definition, where an acid is a proton donor and a base is a proton acceptor. But you don't think of a proton coming from the nucleus. But a hydrogen ion is just a proton. Okay, so now this part gets to be a little bit confusing. What we want to do is we want to identify, according to Bronsted-Lowry, acid-base pairs. So if you take a look at our first example, HCl, well, you know it's an acid, but that's not good enough at this point. We want to find out, how do we know it's an acid from this equation according to the Bronsted-Lowry definition? Well, remember, the definition of an acid is a proton donor. Okay, so when you look what HCl becomes on the right side, it becomes Cl minus, so that means it donated or gave up or lost a hydrogen ion. The thing that it becomes on the other side of the arrow is called a conjugate base. So the other side of the arrow is its conjugate, and it's going to be the opposite of an acid, which is a base. Let's take a look at water. What does water do? Well, water is H2O on the left side. On the right side, it's H3O+, which means it's gained a hydrogen. That's the definition of a base. A base is a proton acceptor. So here it's a base. What it becomes on the other side is called the conjugate acid. Let's look at another example. NH3, you might know this one, but try to forget if you know it, and we're going to figure it out from the equation. What does NH3 do? Well, if you look between the left side and the right side of the equation, it gains a hydrogen ion. Well, according to our definition by Bronsted-Lowry, that means that it is a base. The thing that it becomes on the other side is the conjugate acid. Let's take a look at water. In the previous example, water was a base. Let's see if it is again here. Well, what does water do to go to the right side? It loses a hydrogen. That means that it's actually acting as an acid here, and what it becomes on the right side is the conjugate base. So just to review, an acid loses a hydrogen ion. The thing that it becomes on the other side after it's lost its hydrogen is the conjugate base. A base gains a hydrogen, and the thing that it becomes on the other side has accepted the hydrogen ion. And if you recall from our two examples, water did both. One time it lost a hydrogen, the other time it gained a hydrogen, and there's a word for that. It's called amphoteric. That means it could behave as an acid or a base. Well, that's it for our slideshow for today. If you have any questions as you're doing the worksheet, you should refer to your book. I have the section number on there, and I will see you soon.